All right, this is the p-test. I will give you a proof for this in a couple of sections when we learn something new, but I think it's such an important test and you're going to be using it so often, I want us to start practicing with it. So if I have 1 over n to the p, if that p is smaller than or equal to 1, then it diverges. The sum diverges. If I have 1 over n to the p and p is greater than 1, then the sum converges. So I don't know what it adds up to, but I can say it converges. All right, so I'm just going to rewrite this as n to the 1/2 so we can look at what the p is equal to, just to make sure you're getting very comfortable with this. So here I see the p is 1/2. Right? The p always has to be in the denominator. The 1 over n to the p has to be in the denominator. With p equaling to 1/2, I can say this diverges by p-test. Okay, so let's look at this one. So n equal 1 to infinity. I guess I forgot to write that on this one. Okay, so 3/2 can get pulled off to the side. And then let's make sure we're very careful and you know how to write this as power over root, the fraction, right? So the 5th power over the square root. So looking at this to do p-test, numbers on multiplied times on the outside here doesn't really matter. Looking at this, p is 5/2. I can see that this means this converges by p-test. We're going to use p-test a lot. All right, so let's look at this one. So this gives us 1 over 3 to the 1 over n power. We just did this a minute ago, right? Okay, n equal 1 to infinity. This is not n to the p, is it? This is not p-test. So be careful that you do not use p-test on this. It has to be exactly n to a p power, right? N to a number in the denominator. I think we did one just like this a moment ago where we used the test for divergence. So if I take the limit as n goes to infinity of this, put an infinity up here, I get 0. 3 to the 0 is 1, doesn't equal 0, so therefore it diverges by T for D, the test for divergence. Okay. The n to the p has to be used on separate sums, or 1 over n to the p exactly, so you cannot use p-test the way this is written. So I'm going to need to break it up around the addition in the numerator. So I have 2 separate sums. So simplifying this one, I get 1 over n squared. And then this one is 1 over n cubed. Okay, they both converge by p-test. If one of them diverged, then if you had diverge plus converge, that equals a diverge, because diverge means adds up to infinity. So that overrules everything.